I'm going to present another way to handle these type of problems that some people prefer. It's more mechanical, more step-by-step, but it works just like the other method works. I'm just going to present it here. So let's say that I, again, chose u to be sine x in this problem here. And my du dx would be equal to cosine x, just like before. What we're going to do here is do direct substitution. So I would like to solve for the dx and then replace it in the original integral. So dx is in the bottom right now. So I want to flip both sides. So I would get dx over du equals 1 over cosine x. And then multiplying both sides by du would give us dx is equal to du over cosine x. So now I can use this substitution here and this substitution here in the original integral. And here's what would happen. Okay, sine x becomes u, cosine x stays by itself for now, and then the dx gets replaced by du over cosine x. And look what happens. Those cosine x's cancel out, and I'm left with an integral that only has u's in it. Okay, a lot of people like this method a little bit better. It may take an extra step or two, but it's up to you to decide which way you like best. Okay, let's do one more example using this method. Okay, let's make one up off the top of my head here. Let's go 8 sine of 5x dx. Okay, again, this is not on my list, but sine of u is on my list, so if I could create this into sine u somehow, that'd be good. So let's let u equal 5x. That would mean du dx equals 5. And if I flip both sides, I get dx over du equals 1/5, and therefore dx would equal du over 5. Okay, so once again, I'm going to replace 5x with u. I'm going to replace dx with du over 5 and see what happens. Okay, so I would get what? 8 stays the same. I still have a sine. The 5x becomes u. And my dx, becomes du over 5. So I have du over 5. And now if I look at this, I can take the 8 and the 1/5 outside, and here's my new integral. 8/5 times the integral sine u du. Okay, so if you do it this way, there's no fudging. Extra numbers are going to appear, and then you can just pull them out inside in front of the integral. But it's maybe a step or two extra. Okay, what's an antiderivative? Of sine u? Well, that would be negative cosine u plus c. And then I can replace my u with my original expression in terms of x, which would be 8/5. I'll write it like this: negative 8/5 cosine of 5x plus c.